Welcome to this lecture of calculus. In this lecture, we shall define the absolute maximum and the absolute minimum value of a function, and then we shall prove the maximum minimum theorem, or which is also known as the extreme value theorem. So first we define the absolute maximum and the absolute minimum. So here let's take up the definition. Let A be a set contained in the set of real numbers, and let f from A to R be a function, and let f from A into R be a function. We say f has an absolute maximum. F has an absolute maximum on A if there is a point x star in A. If there is a point, suppose x star belongs to A such that this f of x star, this is greater than or equal to f of x for all x belongs to A. सो एब्सोल्यूट मैक्सिमम का अब मतलब ये है कि हमें पूरे इंटरवल में देखना है जो फंक्शन का अगर सबसे मैक्सिमम वैल्यू अचीव होता है then that maximum value is known as the absolute maximum, and the point at which this maximum absolute maximum value is attained, it is called the point of absolute maximum. Now on similar lines we can also define the absolute minima. Similarly we say f has an absolute minima on A if there exists a point. If there is a point, say suppose let's write star here in the subscript belongs to A such that this f of x star, this is less than or equal to f of x for all x belongs to A. So now this means that कि अगर function का सबसे smallest value attain होता है at some point in the domain of f, then we say that that functional value is the absolute minimum value, and in this case the point x subscript star is known as the point of absolute minima. So therefore we can continue this definition. We say that x superscript star is an absolute maximum point, and x subscript star is an absolute minimum point. Now here let's take up one example. So take a function f from the interval suppose -2 to 6 into the set of real numbers defined by f of x is equal to suppose x plus 2. Then the least value of f, then the least, or we can say smallest value of f of x is f of -2. So this f of -2 in fact, which is equal to -2 plus 2 is equal to 0, and the largest value of f, this is obtained as f of 6, which is equal to 6 plus 2 is equal to 8. We can here clearly see that the function x plus 2, this is an increasing function. So as the value of x increases, the value of x plus 2 increases. So therefore the smallest value will be obtained at -2, and the largest value of this function will be obtained at 6. So hence this 0 is the absolute minimum value of f of x, and 8 is the absolute maximum value of f of x. Now these two values are attained at the points -2 and 6. Moreover, this x equal to -2 is the point of absolute minimum, and x equal to 6 is the point of absolute maximum. So this is how we define or find out the absolute minimum and the absolute maximum values of a function. Now we shall come to the extreme value theorem or the minimum maximum theorem and then take its proof. So now here we have a theorem. This is known as a maximum minimum theorem. Maximum minimum theorem, or this is also known as the extreme value theorem. This theorem states that let I is equal to the interval AB be a closed bounded interval, and let f be a function defined from I into the set of real numbers, be continuous on I, then f has an absolute maximum and an absolute minimum on I. Now let's take up the proof of this theorem. But before taking the proof, we shall recall the boundedness theorem. So this is recall. This theorem states that a continuous function defined on a closed bounded interval is closed bounded interval is bounded. Now we can take the proof of the maximum minimum theorem. So by boundedness theorem, the function which is f defined from the interval ab into r is a bounded function. So this is a bounded function. So now what we mean by bounded function, so this means let m is equal to supremum of f of x such that x belongs to the interval a comma b. Now we are defining this quantity m. Since our function f is bounded, we are defining the largest value that f of x attains is m at some point x in the interval a comma b. And we need to show that the function f attains its absolute maximum and the absolute minimum. We shall again prove this theorem by a contradiction. Assume for a contradiction that f of x is less than m, for all x belongs to a comma b. Then the function which we shall define as g of x, which is equal to m minus f of x, this is greater than 0 for all x belongs to a comma b. So what we have done here, तो अब हमने यहाँ पे लिया for a contradiction f(x) is less than m, तो इस इक्वेशन से हमें मिलेगा m minus f of x is greater than 0. अब इस m minus f of x को हमने नाम दे दिया फंक्शन g of x. Now consider the function. Let's define a function h of x, which is equal to 1 divided by g of x. So this function is actually 1 divided by m minus f of x. Now since this m minus f of x is greater than 0, so therefore this h of x is again a continuous function. So then as this m minus f of x is greater than 0 and continuous, therefore the function h of x is continuous on the closed interval a comma b. So when this function is continuous on the closed interval a comma b, therefore this function must also be bounded on the closed interval a comma b. Hence by boundedness theorem, this h of x is bounded on this closed interval a comma b. So this means there exists a real number k greater than 0 such that this h of x is less than k for all x belongs to, or we can say less or equal to k for all x belongs to the closed interval a comma b. Now what is our value h of x? So this implies 1 divided by m minus f of x. This is less or equal to k for all x belongs to the interval a comma b. So now this implies, now taking the reciprocal, this implies this m minus f of x is greater than or equal to 1 divided by k for all x belongs to a comma b. And this step is obtained by taking reciprocal. Then this gives, so this implies this function f of x, now this is less than or equal to m minus 1 divided by k for all x belonging to the closed interval a comma b. So we have just manipulated or simplified this expression and shifted this f of x onto the right hand side and shifted 1 by k onto the left hand side. Then this f of x becomes less or equal to m minus 1 divided by k. But now here at this stage, so since this k is greater than 0, this implies m minus 1 divided by k. This is strictly less than m because k is greater than 0, so we are subtracting some positive quantity from m. So this implies we have this f of x is less than m, and this is true for all x belongs to the closed interval a comma b. So which is a contradiction? Which is a contradiction. Now why this is a contradiction? We have earlier assumed that the supremum of f of x is equal to m. लेकिन so इसका मतलब ये हुआ कि at some point x belongs to a, b, we have f of x is equal to m. लेकिन अब हमने यहाँ पे प्रूव कर लिया f of x is less than m for every x in a, b. तो इस तरह से जो हमने ऊपर सुप्रीमम डिफाइन किया था that some x in a, b we obtain the value m at some point f of x at some point x. तो वो उसके साथ अब यहाँ पे contradiction हो गया that we have for every x belongs to a, b fx is strictly less than m. So this contradiction shows that there exists c belonging to the interval a, b such that f of c is equal to m. So this m is therefore the absolute maximum. Hence f of x attains the absolute maximum. Now on similar lines, if we consider the function, now consider the function minus f of x, we can show f of x has the absolute minimum. तो इस तरह से यहाँ पे अब प्रूफ को रिपीट करने की ज़रूरत नहीं है. अब अगर हम f of x की जगह पे फंक्शन माइनस f of x लेंगे तो हमें माइनस f of x will have the absolute maximum. तो वही f of x का actually absolute minimum होगा. So therefore this completes the proof of this theorem. Now let's take up one example here. The function f of x is equal to, suppose, x cube minus 3x. This is continuous on the interval 0, 2, which is a closed and bounded interval. Therefore the above theorem, or the extreme value theorem, this guarantees that this function will have the absolute maximum and the absolute minimum. Then how do we find them? We have to check the critical points. So then f dash of x is equal to 3x square minus 3. Suppose this is equal to 0. This implies x is equal to 0, 3, 0, 1. Then in order to find the absolute maximum or the absolute minimum, we will have to find the value of this f of x at x equal to 0, at x equal to 1, and the boundary points of this interval. So then f of 0, this is equal to 0. F of 1, this is equal to 1 minus 3, which is equal to minus 2, and f of 2, which is the boundary point of the interval, this is equal to 8 minus 6, which is equal to 2. तो इस तरह से हमें यहाँ पे एक रूल है टू फाइंड एक्सट्रीम वैल्यूज़ और द एब्सोल्यूट मैक्सिमम और द एब्सोल्यूट मिनिमम वैल्यूज़. तो उसके लिए सिंपल रूल ये है कि पहले हमें stationary points निकाले हैं और we have to find the critical points, which mean by saying that we have to find the derivative of the function and equate that to 0. और जो points हमें वहाँ से मिल जाएंगे they are called the critical points. इन सब critical points पे हमें f of x का वैल्यू निकालना है और उसके बाद जो गिवन इंटरवल होगा उसके एंड पॉइंट्स पे हमें फंक्शन का वैल्यू निकालना है. तो इन सब वैल्यूज़ में से जो सबसे छोटा वैल्यू होगा दैट विल बी द एब्सोल्यूट मिनिमम, और जो सबसे बड़ा वैल्यू होगा दैट विल बी द एब्सोल्यूट मैक्सिमम. So hence this f of 1, which is equal to minus 2, this is the absolute minimum, and f of 2, which is equal to 2, is the absolute maximum. So now here we shall mention the rule that we have used here to find this absolute maximum or the absolute minimum. So this is algorithm for finding the extreme values, for finding the absolute values, absolute minimum and absolute maximum values. The first step is given f of x. Now the second step is find f dash of x and equate f dash of x to 0. So given f of x on, suppose, the interval a, b. Now the third step is find values of x such that f dash of x is equal to 0. Suppose we obtain x is equal to, suppose, x naught, let's write it from x1, x2, so on, xk. Now these points are known as critical points. Then the final step is the step number 4. Evaluate this f of x1, f of x2, so on, f of xk, and also evaluate f of a, comma f of b. Then the final step is the largest value obtained in step 4 is the absolute maximum, and the smallest value obtained in step 4 is the absolute minimum. So here we conclude this lecture.